What if Mars, the red planet, long thought to be cold, silent, and lifeless, is not so dead after all? What if swirling dust storms and ghostly dust devils quietly spark tiny bolts of electricity, crackling the thin Martian air unseen, unheard, until now. Today, NASA dropped a bombshell. Mars might be alive, with many. This discovery could flip everything we thought we knew about Martian weather, atmosphere, and the future of exploration. Stick around, because the red planet just got a shocking new voice. Since its landing on Mars in 2021, NASA's six-wheeled rover Perseverance has been traversing the red soil of the Jezero Crater, once believed to have hosted a lake billions of years ago. Scientists sent Perseverance with many goals: to collect rock samples, hunt clues of ancient life, study geology. But one thing nobody expected to catch for real was sound. Perseverance carries a sophisticated instrument known as SuperCam, designed to scan rocks, analyze chemical composition, and record environmental data. Among its suite of tools is a microphone, intended to catch the wind, the rover's own noises, maybe the whir of its helicopter companion. But what the microphone recorded recently changed Martian science forever. For decades, scientists speculated that Mars, with its fine dust, dry surface, frequent dust storms, and dust devils, could generate static electricity. Computer models, lab experiments with Martian soil simulants, and theory all pointed to the possibility of charge buildup, even sparks. But until now, there was no direct evidence. That changed in late 2025, when researchers announced they had detected what they called triboelectric discharges, tiny electrical arcs inside Martian dust storms. The evidence came from hours of SuperCam audio and electromagnetic recordings spanning 2 Martian years. The discovery, what really happened, scientists reviewed around 28 hours of audio captured by SuperCam, collected over 2 Martian years. They found 55 separate instances of electrical discharges in the Martian atmosphere. Most of these events coincided with dust storms or dust devils, swirling whirlwinds of dust common on Mars. The friction between dust grains, rubbing and colliding in the thin, carbon dioxide-heavy atmosphere built up static charges, a process known as triboelectricity. When enough charge accumulated, it discharged as an electric arc, just a few millimeters or centimeters long. Unlike Earth's dramatic lightning bolts that light up the sky, these discharges were tiny, more like a static spark you might feel on a dry day when you touch a metal doorknob. Scientists described the sound as a sharp crack or zap, faint but distinct, even against the background of howling Martian wind and shifting dust. Importantly, this is the first direct evidence ever of atmospheric electrical activity on Mars. Never before has a rover recorded such phenomena on the red planet. This discovery marks a major milestone. Mars may not just be a geological fossil, but a dynamic planet. Still active, still surprising. What it means, implications, and why it matters. A new view of Martian weather and atmosphere. If Mars can generate electrical discharges, then its atmosphere is far more complex than previously believed. Dust storms and dust devils do more than move dust. They may shape how dust is transported, how storms evolve, and perhaps even influence climate cycles. The static charges could affect dust behavior, causing clumping, lifting, more rapid dust mobilization, all with consequences for surface chemistry and climate. Chemistry, surface conditions, and habitability considerations. Static discharges don't just spark. They release energy that can alter atmospheric and surface chemistry. On Mars, these zaps may produce oxidizing compounds. In theory, those compounds could degrade organic molecules or alter gases, like methane, which many scientists are studying as potential signs of past or present life. This means our ideas about what Mars was or could be may need serious rethinking. Implications for equipment, missions, and future humans. This is critical for future exploration. For robotic missions, even small static discharges might interfere with sensitive instruments, electronics, or data collection. For future astronauts, if humans ever set foot on Mars, These static storms may pose risks to equipment, habitats, and safety systems. Engineers will need to design for a world not just dusty and cold, but electrically active, changing the narrative. Mars is not dead. It's alive in its own way for decades. Mars has often been portrayed as a silent, eternal desert, dusty, cold, and lifeless. This new evidence shatters that image. Mars is dynamic. Its atmosphere breathes, moves, charges, and occasionally crackles. It's alive in its own ghostly way. What we still don't know, the open questions. The discharges recorded were tiny. No massive lightning storms, no bright flashes, only audio and electromagnetic signatures, not visual evidence. That means some scientists remain cautious. We might interpret them as static discharges, not classic lightning. We don't know how widespread or frequent these events are across Mars. The data come from a single location, the Jezero Crater, and over a limited time. How common are such zaps elsewhere? Are they seasonal, regional, global during storms? What are the long-term effects on Martian climate, dust cycles, and surface chemistry? Could these discharges influence stability of any organic molecules? Could they shape habitability zones? All these remain open to research. Key takeaways. What you should know: Mars isn't silent anymore. The detection of mini lightning shows the Martian atmosphere can produce electric discharges, the first confirmed evidence of atmospheric electricity. On Mars, dust storms and dust devils do more than move dust. They create static electricity, sparks, and may significantly influence dust transport, surface chemistry, and climate dynamics on Mars. Future exploration. Robots or humans must adapt. Martian dust storms are now a source of electrical activity. Missions must account for potential static discharges, both for equipment safety and for understanding chemical atmospheric consequences. Mars is whispered a secret, not with thunder or blinding lightning, but with faint zaps, invisible sparks cracked by dust storms. But those tiny arcs may rewrite what we know about the red planet. Its weather, its atmosphere, its potential for future explorers. If you're fascinated by cosmic mysteries, planetary surprises, or the future of space exploration, hit subscribe on AED. Ring that notification bell, because every spark, every zap, might lead us closer to a truth no one saw coming. The universe is speaking. Are you ready to listen?